So that was a really cool commercial that our friends over at Lowe's put together, a partnership we're doing with them, with the printer that's on the space station right now. So this is actually, the one you just saw is our second 3D printer that's up there, and I'll talk about both. But we're building things for astronauts right now, as Salim said. When they need something, sometimes getting it there by 3D printing, it's a lot faster than sending it on a rocket. We also have commercial users, which is really interesting. We're building everything from satellites on the space station on demand to new experiments that are driving new breakthroughs in science in space. So today I want to talk about kind of my big idea, this kind of what's driving me to why we created this company. But first, a little bit about myself. I come from this really interesting place in the universe called Silicon Valley. It's not quite the center of the universe, but we like to think that it's damn near close. It's this place of moonshots. We've heard that a lot the past 2 days, this idea of moonshots, right? Crazy ideas. So what we're working on in Silicon Valley, quite literally, are moonshots. We're working on ways to get people in space sustainably, living there comfortably. So this leads to kind of my big idea. This is a question I've been asking myself for the past 6 years as we've been building this company. And the question is a planetary surface really the best place for our advancing industrial needs? It's an interesting question, right? It's something that I'm sure none of you have really pondered. So how I got to asking that question is really the story of how I got into space. I've always been focused outwards. How do we get people living on Mars or back to the moon? About almost 10 years ago now, Peter Diamandis told me that one day in our lifetime we will irreversibly leave planet Earth. And I thought that was really an intense statement, that in our lifetime we could irreversibly leave this planet. And I thought to myself, what else could I ever work on than that most important evolutionary step that we would ever take? So I've always been thinking, what does the spacecraft of the future look like? How do we build a sustainable ecosystem? How do we build this closed loop environment so that people can live anywhere they want? And the more I looked at the problems that we currently have in spaceships and how we keep people alive, the more I realized what's actually something that some other speakers have talked about over the past 2 days, that Earth also has these challenges, right? Earth is a closed loop system. Earth is a spaceship. We're all space explorers. It's just a good chance none of you have ever left the spaceship. I know I haven't. So that leads into the other spaceship, the International Space Station. And I want to tell you one of my favorite stories of what we've done with the 3D printer up there so far. This is a story about Butch Wilmore, pictured here, and his ratchet, a tool. So one day, Butch radioed down. We actually control the printer from a mission control room in Silicon Valley. And we're on a headset, and one day Butch mentions that he has lost his ratchet, a wrench tool. And he didn't ask for a new one to be printed. He was just mentioning that his was missing. And we had about 5 days until we would print the next part. So we started to think, maybe we could design Butch a ratchet, get it qualified by NASA, and send it there digitally. Now I have this picture up here to really point out how easy it might be to lose a ratchet in the space station. The space station today is not like the picturesque 2001 Space Odyssey type space stations. These are cluttered, compact, really tight living environments with things all over the place, and everything's in weightlessness, right? So maybe Butch just let go of his ratchet. He didn't set it down. He just let go of it, turned around, it floated away. Perhaps it's inside that spacesuit, or it's behind that tangle of wires in the back. Nonetheless, he lost his ratchet, and that could be an important problem to solve. So it starts for us in design. And this is one of the most interesting things about manufacturing in space, the way we do it, is that everything starts digitally on a computer designing it. And then the digital information is sent to space, and we print it out. So that means that we don't have to ever design, we don't have to create anything that could exist here on Earth. Maybe it can only live in the digital world on the computer and this really unique aspect of space. And this idea of going from digital to physical is really the essence of what we're doing, digital manufacturing. I don't know if any of you else noticed this, but I love this sign, how it's like a digital SU shield going into the physical shield. I mean, it's just like the same idea all over the place. But here's the ratchet. We designed this ratchet in a matter of 1 day. We tested it on our printer in our lab. We then sent NASA a couple copies, and we let them go through a safety review. This would be the first time NASA would ever hold in their hand not the real thing going to space, but something that we said, trust us, when we print this in space, it'll be pretty much the same. So they held it, they decided it was safe enough to go, and the way it works is once you get past the safety review, we start to uplink it. So we have a little ground station in Silicon Valley at our office where we take the digital information and we send it to the space station. Here we are transmitting it. It goes from our ground station over to a NASA ground station in Huntsville, Alabama, where it gets uplinked onto the space station and installed on the laptop computer you see in the front of the image. Then the printer is inside that big glass box. You probably saw Butch in the video we watched earlier manipulating the printer. What's interesting is that the printer is, like I said, controlled from the ground by our team at Made in Space. So for the astronauts, they never really know exactly what we'll print. They're there to remove parts, open the door, take a part out, close the door, get it ready for the next print. They never really know what we're going to print. So to them, it's this magic box in space where every time they open the door, something new is inside. And we've watched this excitement where it goes from the first set of prints are really basic, couple layer pieces of plastic up to things like a ratchet, and the excitement of the astronauts to see this happen. Here's Butch going to open the door of his magic box with the ratchet inside. The last time we heard from Butch was 5 days before this picture was taken, when he said, I lost my ratchet. And he has no idea what's inside when he's opening this, when this picture's taken. And then my favorite picture of all, I call Happy Butch, but it's him holding his ratchet. This picture was taken 2 hours after we sent the digital information to space. Think about that. We sent digital information of a physical part into outer space, and 2 hours later, the astronaut's holding the physical object in his hand. If Butch were on Mars, the story I'm telling you would be almost identical, because we're sending things at pretty much the speed of light. So this is really incredible, and to really help that set in, I'm going to tell you a story that starts at the beginning of space exploration. This is Yuri Gagarin, April 12th, 1961. He becomes the first human being ever to leave planet Earth. He got there on the pinnacle of technology of the time, the Vostok rocket. He launched from the Baikonur Cosmodrome. And now we fast forward 55 years later, when people like Butch Wilmore go to space. Nearly over half a century of space exploration. And how do we send literally every single person into space today? Well, we do it on none other than the Soyuz rocket. They almost look identical, right? And that's because they actually are, in many ways, identical. The Soyuz rocket came into operation only 6 years after Gagarin took his historical first flight into space. So no matter what, if it's the Soyuz, the Vostok, even the space shuttle, they all use the exact same technology. It's chemical propulsion. And that's really the heart of the problem of how we've been doing space for the history of space, is that only 2% of that rocket is the thing that we want in space. The other 98% is the structure of the rocket, the fuel, the engines, and all the other stuff to get that 2% there, because it takes a tremendous amount of energy to get off of the bottom of what we call Earth's gravity well, right? It's a huge amount of energy. The Apollo astronauts in this picture were traveling 10 times the speed of a rifle bullet to escape the gravitational pull of Earth. And anything we've ever sent beyond Earth's gravitational pull has had to travel that fast, 10 times the speed of a rifle bullet. Try to put that in perspective. It's really hard. So the supply chain to space is broken. And for everybody in this crowd who's manufacturing, it's easy to think about supply chains and how 3D printing can disrupt them. But to us, that was kind of the big idea, is that the supply chain to space is broken. It's, the rocket problem has existed this whole time. The supply chain means we put rockets on barges and ship them across oceans. Some rockets even have to fit on a train track to get to the launch pad. That means that the width of a rocket is determined by the width of a train track. And since the size of anything we've ever put into space has to fit into a rocket, that means the size of the things in space are determined by the width of a train track. Just imagine the things that we've never been able to do just because of that one fact. So the cost then becomes a big problem. 1 liter of water in low Earth orbit costs $10,000. It's $10,000 a kilogram to put things into space at today's launch cost. So when we started Made in Space, we recognized that a lot of people have been trying to solve this problem. They've been looking at how to make better, faster, cheaper. We've seen a lot of reusable rockets now. But we asked a fundamentally different question. We challenged the status quo. We said, what if one day everything in space could be made in space? What if, in fact, you didn't need to launch anything at all? So what would that look like? What if we didn't have to launch anything at all? Well, first off, the satellites that we put in space would be far larger than what you can fit into a rocket. Imagine communication satellites that are essentially just gigantic antennas the size of a football stadium with microelectronics built into the structure that could provide global broadband internet to the entire planet. Or gigantic truss elements that could support future space station designs or shared platforms in space for international users. So this is actually what Made in Space is working on. We have printers on the space station it's a service and it's a product that we provide, but all of that technology is building towards the ability to do this, and we're working with NASA and industry partners to actually do this right now, and we're under contract, and in the next few years we'll start to make some real missions happen. So Brad Templeton actually stole a little bit of thunder here, but I love this story of New Horizons. Spacecraft was designed to go to Pluto, and it got there just recently, and we saw these amazing images of Pluto. But what's astounding is that it launched 10 years before it ever made it to Pluto, and some of the software needed to actually image the planet and show us all those beautiful images wasn't developed when they launched. In fact, the software team was developing their software while the spacecraft was flying to Pluto, and when it was ready, they uplinked it there. And that's exactly what Made in Space is doing, but with hardware. We're making it so that you can send 3D printers into space and not ever have to know what you need until you need it. Imagine a printer that's in space and 10 years later builds something. So what matters is what we build and not really how we build it. How we build it is the magic box. What matters is what we build, not how we build it. And to help that sink in, I'd like to make this analogy. These are the women of Apollo. Most people don't know this story. We know the story of the men of Apollo, the first people to walk on the moon, but we seldom know the story of all the women who actually got the men there and got them back safely. The women of Apollo in the 50s and 60s working at JPL had the profession of being a computer. A computer used to be a job, not a device. And they made all the calculations to get people all the way to the moon and back. And the idea of a computer profession was well known, and there was a lot of people who had that job until the technology came along and those people became the users of the computer, and the mentor, the guide. They got the things out of the tool that they needed. Today, every single satellite is designed by engineers. That means everything we ever put into space has to first be imagined by our brains, and it has to be created with 2 hands, a mouse, and a keyboard on a computer. Think of the limitations that we have on design. But now software is starting to catch up and do more of the engineering for us. So we're working with Autodesk on how to take generative design to space, where you, instead of having the engineer do all the work, the engineer becomes the mentor to the engineering software, the guide, if you will, and describes the problem space, says, I need an antenna that's the size of a football stadium and provides this bandwidth and this shape tolerance and is in this orbit. And the software iterates through thousands and thousands of different options. And it's all done on the cloud, and it's all done fast. So where the engineer may come up with 3 ideas that arguably can be designed in CAD and probably built by hand, the software comes up with thousands of the best solutions, and most of them can only be 3D printed. They're just too complex to build any other way. So the future of spacecraft in space is really wild because we design them using software, and we come up with the most optimal structure, a structure that maybe wouldn't support its own weight in this room because in the software, gravity is turned off. So the best answer is an answer that wouldn't survive launch into space. It only can exist there. So what matters is what we build and not how we build it. But the key to join those two is the fact that it's not really about manufacturing that's so important in space. It's about new processes. When we think about giving software instructions to design a new space structure, we're teaching the software about the space environment. We're saying you have weightlessness, you have this solar radiation pressure, and all these things, and it's designing based off of those knowns. So what's really happening is we're looking at some new types of processes that we can create in the space environment. And what's really important to understand is that new processes historically have unlocked new industries. And I'd like to share a couple examples. The first one, 17th century England, the hardwood birch tree forests are all being just cut down, decimated, because they're being used to burn them for energy. And England knows that they're running out of this hardwood forest, right? And they know it's a problem and that they have to solve it. They also know that in these deep water-filled mines at the bottom is coal. However, there's no way to extract the water out of the mines to get the coal until a gentleman named Abraham Darby comes along and invents a new process called the coke oven. And the coke oven allows for the extreme temperatures to create steel. The steel is used to build pumps. The pumps get the water out of the mines. And now England has access to an abundant source of coal to drive their industry forward. So now with the coke ovens and coal, more steel is created. And that leads to the machine age, or what we know as the first industrial revolution. So think about that. One new process is invented, and we have the entire industrial revolution. All of the technology we depend on today starts building upon that one set of process. Another example, what do these 3 pictures have in common? I'm sure all of you know it. Okay, right, I'm hearing it now. It's all aluminum, right? And Peter gave a really great opening keynote explaining this, but what's amazing is that aluminum is so abundant, right? We crumple it up and throw it away. It's strong enough to make a laptop out of. It's high grade enough that we can build our space shuttles with it. And aluminum wasn't always that abundant and that affordable and that readily available, right? We know that it used to be something only that kings had the luxury to use. So what happened was a new process was born. Charles Hall, he's age 23. He's in his Oberlin College class in Ohio when his professor says, the person to invent a cheap form of aluminum will surely be rich. Charles goes home, his sister's a chemist, and the two of them figure out a way to use electrolysis to extract aluminum from fluoride salts. And then the rest is history. Aluminum becomes one of the most readily used materials on the planet, all because of the invention of a new process. It was always there, it was the new process. So I ask, what new processes might we create in space? What does the space environment hold for us in terms of the future of manufacturing? And after thinking about this a lot, I think there's at least 5 unique aspects of the space environment that I would like to share with you. And I think it's these unique aspects of the environment that maybe give us hints at what we might be able to do in terms of creating new processes. The first one, probably the most obvious, is gravity, right? Or maybe the lack thereof. In space, everything is in free fall. We call it weightlessness, but it's just in free fall. So it means you have 0 gravity. It also means that with a centrifuge, you can spin up and have any gravity you want. You could have controllable gravity, which might be a really interesting thing to have if you were to create a new process. The next is matter. every manufacturing process needs a resource to start with. In space, it's abundant. We have the asteroid belts. We have the surface of the moon. Matter is abundant. My favorite is radiation. When you think about it, every industrial process on the planet has to follow, any process has to follow the laws of thermodynamics, right? So the second law says that there is always waste heat or waste energy created. So what do we do in our industrial processes? We create smokestacks and we dump our waste heat into the atmosphere, or we put it into the ocean as our heat sinks. In space, you have unlimited radiation potential. If you face something towards the blackness of space, that is the best black body radiator in the universe. So your industrial processes are more efficient. That also means you can control how much you radiate. And along those same lines is temperature. We have a fusion reactor in the sky called the sun, and in space it's unfiltered. You can collect that and use it. And if you have a large enough collector, you could melt the hardiest of metal alloys and build things with them. And eventually, even energy density is at our control when you think about entire star systems and the densities that exist throughout the universe. So how might we use these? Maybe a couple ideas. One of my favorites are the ideas where we take industrial processes on Earth that are incredibly damaging to our environment, and we all know it. We just don't know what we can do about it. Imagine taking mining activities off of the surface, and this will happen one day because at some point we will run out of the resources on the planet and we will have to transition off planet. It will just economically make more sense. But in space, mining may be a lot more efficient than here on Earth. First of all, the asteroid belt, we know there's asteroids there that contain more nickel iron than all the iron ever mined on the planet. So there's a lot of the resource we need. But the way we do the mining may be different because of the new processes. Anybody in this crowd could pick up a giant asteroid and move it when you're in zero gravity, right? So moving giant objects is easier, and that's just the beginning. What about agriculture? Perhaps the future of agriculture is to do it off of planet Earth, where we don't pollute our rivers and streams any longer. Instead, we build in Earth orbit big cylinders that rotate on their long axis to create some gravity, and we grow our plants there. And we have the ability to filter in exactly the right amount of sunlight that we need for the right amount of time during a day, so you have a perfect growing season, the perfect temperature, give it any season you'd like. You can grow the best plants, and not to mention there won't be any bugs or pests because you're in space. So I come back to the spaceship, and I think about what we're doing at Made in Space to help people live off of planet Earth and help change the way we do things in space. I'm a total believer that in our lifetime we will irreversibly leave planet Earth. We will find a way to live on Mars and build habitats on the moon and build cities in space even, and I want to see that happen. I think the technologies that we will have to do that will change life on Earth. But no matter what, we have to admit Earth is a pretty good place. It's pretty nice here. Earth wants to keep us alive. It's the only place in the universe we know of that really loves life. I would go as far to say that maybe all of life as we know it has evolved to live here. But we need to take care of the planet. I don't think anybody would argue against this. We've heard a lot of people say it, speaking here. We live in a closed loop system. Earth is a closed loop system just like the ISS or any other spaceship we've ever built. It's just bigger, so it's harder to see the impact as quickly. There's a dark side of industrialization. The path of all of our industrial revolutions is just building upon this, right? Like I said, we dump our waste heat into our atmosphere, into our oceans. We turn mountains into giant holes in the ground to get resources. And this can't continue on forever, can it? How many mountains can we turn into holes in the ground? What happens when the 3 billion new mines come online that we heard about, and they all want access to products? Do we have enough resources on the planet to start building products for 3 billion more people? I don't know. So I come back to my question, is a planetary surface really the best place for our advancing industrial needs? And in my mind, the answer is inevitably no. There's absolutely no way that inevitably it will always be the best place. So the question is, how soon do we make the transition? And I leave this question up to all of you to ponder as well, because as people from the manufacturing industry, you're all just as responsible as I am to making this happen and to thinking about how soon it can happen. It doesn't have to be something that we consider as a, hundreds of years from now, maybe this is going on. This is literally could happen today. So I thank you for your time, and hopefully we can talk later. Thank you.